So here's the test. Okay. This is a very typical test for a chemistry test because it has both objective questions, multiple choice, that kind of stuff, as well as math problems. Plenty of both. If you look at the front side, okay, first 7 questions going to be on the modern atomic theory, the particles, protons, neutrons, electrons. You should know where they're located, their charge, their mass, all that kind of fancy stuff that we talked about under the modern atomic theory. The next 10 questions you've got are going to be on the scientists for the most part and the history of the atomic theory. All right, so you have to look over those experiments, Thomson, Rutherford, Millikan, all those guys. Then you've got the same chart you're going to see right there. The same chart's right here. Okay, fill that in. There's a couple more multiple choice underneath that. The back, top, problem just like that, number 4. And underneath that, all the rest of those, there's about 6, 7, 8, 9 more, are going to be these conversion problems. All right? So you can see the majority of the test, the back in particular, all of the back is math. And the chart is on the front, too. So over 50%, probably more like 60 or 70% of the test is going to be math-oriented. Now, the other 30 or 40% of the test, I can't help you with. You got to study that. I've already taught it to you, but you're going to get it mixed up. So, Democritus, Dalton, Thomson, Rutherford, Millikan. I mentioned those names right now. They mean nothing to you. You're going to have to study them. But that's all you have to do is study them. You memorize what I told you about, I give you the notes, you're going to be okay. Other things are confused easily. For example, atomic mass, atomic number, mass number. They all sound alike, but they're not. You have to know those. They'll also be in multiple choice format as well as using them in these kind of charts and stuff. Okay? Ion, isotope. You got it mixed up the first day after I taught it to you. Let you use your notes, and you guys mixed them up. So chances are, if you don't study, you'll get those mixed up. Now, I can't help you with that studying part, but I can help you with this. Let's go over all the math problems. I'll go over exactly how to do each one. Is anybody absent yet? Was anybody absent yesterday? Okay, well, then you should be all pretty well caught up. I had a lot more. I know, Nick, you were absent a lot, but there was in your class, I had many more people absent either yesterday or Monday or both. All right, in this class, there was nobody here yesterday, so you should have used that time to get caught up. And my guess is you probably are caught up. All right, let's go over these first. I'm going to show you how to do each one of these. And actually, the procedure that you use is exactly the same procedure you used to do the metric conversions. All right, let's start it out. What do I write down first here? Marvin?
49 grams.
49 grams. You write down the given information first. That's pretty much the first step in a lot of problems. Okay, I write down the given information. And then I'm going to convert. I'm going to do a simple conversion. I don't care what I'm converting to. What units have to go on the bottom here? Karen?
Grams.
Yeah, grams go on the bottom. How come? The grams always go on the bottom, Ellie? Yeah, they go on the bottom because they have to cancel. Because there were grams over here. That's why you write the units down every time. They kind of lead you down the garden path, where to go. You also know what goes up here, not because you memorized it, but because it makes sense. What does it want me to convert into? Moles. So I put moles up top. So I've got moles on the top, I've got grams on the bottom. Rebecca, what goes next to moles every time?
1.
Yeah, and she knows that because there is some memorization, kind of like there is some memorization involved even in the metric conversions. You kind of have to know what's in that box. I had to put a big box around it back when you did it in your notes, and I've been leaving that box up there. It will not be up there tomorrow. Okay, you have to know what's in that box. Moles. 1 mole equals 6 × 10⁻⁵ atoms, which equals the atomic mass in grams. Now, I explained why all that happened. If you don't remember how, you can watch it again. It's online. But whether or not you understand it makes absolutely no difference to getting these problems right. Because all you have to remember is next to moles every time is going to be a 1. Next to grams every time is going to be atomic mass. And the atomic mass of phosphorus is, I hope you all wrote down, 30.974. Now, if you do the math for that, what'd you get for your answer, Emily?
1.6 moles.
So you got 1.6 moles. Does everybody agree with that? Okay. If you don't have that, you have different number of significant figures. It's 1.6. You have 2 significant figures because he only has 2. And you're limited not by this number. That does not limit you. The 1 mole, the 1's an exact number. This number would limit you. That number would limit you, but not the 1. That's an exact number, not to say it's not a measured number. Okay, let's do the next one. What do I write down first for this guy, Emily? This Emily.
45.0 moles.
Oops. All right. 45.0 moles. Now, if you notice, last time moles is on the top. What's going to be on the bottom this time, Nikki?
Moles.
Yeah, because they have to cancel. Moles have to cancel, they go on the bottom. What's going to go on the top, Josh?
6.02.
You don't do it that way. You ask. You don't do it. That's not. You wouldn't know that yet. What units go on the top? Using the same logic we've been using to solve these problems. Atoms. I know. I just go by units first. Then I fill them in. Because once I know there are moles going on the bottom because there are moles up here to cancel, atoms go on the top because that's what it's asking me for. Now I can fill it in. What goes next to moles every single time? A 1. What goes next to atoms every single time? That number. Avogadro's number. Again, I tried to explain it. Hope you understand it. But even if you don't, that's all that matters is what's in that box. Now, it also matters how you plug it in your calculator. It's not worth a lot of points, but you should do it right. If you do it right, what do you get? And I'll tell you, I've been grading those papers today, and a lot of people are not plugging it in right yet. You would plug in 45.0 times 6.022, then what? EE or EXP, whatever your calculator says. Do not hit 6.022 times 10 EE. You'll be off by a decimal. It's 6.022 exponent button, 23. And you get what for your answer here? What'd you get for your answer, Josh?
7.058. 2.70.
Well, which one?
2.70.
Right, 2.70. Anyone else get that?
No.
No?
Not 2.71.
2.71. Anyway, it's not finished either way. Times what?
Times 10 to the 25th.
Times 10 to the 25th. Anyone else get that? And also, you need atoms. Okay, now, assuming that's correct, is it the right number of significant figures? Yes. Would he lose any points? I don't know which is right. I didn't do it. 2.70 or 2.71, I don't care. Neither of those is going to cost you a point for rounding up or rounding down. What would cost you a point is if you wrote 2.7 times 10 or whatever. Oh, and here's another thing that cost you a big point, a big fat point. 2.71 E, I hate this, 25. Don't just write E or EE 25. I'm not asking you how to plug it into a calculator. I'm asking you for the mathematical number. Okay, it's not, don't tell me the EE button or the E button. Here, this would be just as bad or worse. 2.71, 2 to 25th power. Also very bad. Big difference between that and times 10 to the 25th. Okay? Oh, and the other mistake I saw as I was grading, these are all fresh in my mind, people who just left out the entire exponent. You just forgot to write it down. And that's easy to do because in some of your calculators, they move it way over to the side and you kind of miss it. So don't do that. All right, let's write this next one down here. Jared, what do you think I write down first?
12.67 grams.
All right. This, Josh, what do we put in the bottom?
Grams.
Top?
Atoms.
Okay. And you know that because grams cancel and I'm asking for atoms. What goes next to atoms every time? Same number I've been putting there. Avogadro's number. What goes next to grams? Zach.
10.811.
Yeah, now it doesn't always go there, but it goes there because the atomic mass goes next to grams. There's grams. Atomic mass goes there. Atomic mass of boron is 10.811 grams. Do the math for all that. Once again, if you do it right, this times that divided by that, you should get what for an answer, Bob?
7.058 times 10 to the 23rd.
Let's see if everybody agrees with that. 7.058 times 10 to the 23rd. One more thing. Atoms. Okay. Oop. That's all. Okay, good. Everybody got those? That is the whole, almost the whole backside of the test, doing those kind of problems. Why are there so many? Because I can ask them so many ways. I can ask them going from grams to moles, grams to atoms, moles to moles, moles to grams, moles to atoms, atoms to moles, atoms to grams. You know, I could ask it a lot of different ways. All right, next there'll be one like this. Was anybody absent on Monday when we covered this? Okay, Nikki was in here. Would have been here. She hadn't been bleeding all over the hallway. This one I'll go a little slower with because we only did do it Monday, and I wasn't here yesterday. So we'll go a little slower on this one. Here's what you have to do. You have to get what's called a weighted average on this guy. Okay? To do a weighted average, you have to take these percentages of each of those masses. 10% of that mass, 78% of that mass, 11% of that mass. That's a weighted average. How do I get 78.7% of a number? Well, I told you when we did this, 50%. If I wanted to get 50% of 40, you all know the answer is 20. You know, but the reason it's 20 is because 50% means 50 out of 100, which is 0.5, right? 0.5 times 40 is 20. Okay? Half of 40 is 20. That's why it works. And that's what you do every time. You simply move the decimal place over two spaces because you're dividing by 100 for a percentage. I move this decimal over two spaces, and I multiply 0.7870 times that mass. Let's do that. So for MG24, I'm going to take 0.7870 times 23.983 AMUs. And what'd you get for that number, Zach? What'd you get for that number?
18.87.
18.87. Anybody else get that? Good. All right. Now for magnesium 25, Nikki, what will I multiply for this guy?
0.1018
Correct. Times 24.986 AMUs. Okay, what'd you get for that mass, Mark?
2.53.
Everybody else get 2.53?
No.
Should be one more significant figure. 0.531?
Yeah.
Is that better? Okay. You notice, on review days, I don't have the problems worked out usually. Okay? Because with all you people doing it, I'm simply checking, why don't I care? Because when you get this whole problem done, if you made a calculator error, it's going to cost you 1 point. I told you that many times. I don't care about calculator errors. And I can usually tell from all you people doing it what's the right answer. Anyway, I will be pointing out, and I can usually pick out the mistakes by just looking at the significant figures, scientific notation, or units being left out.
So if I rounded 18.87 to 18.88, is that going to be bad?
Well, I don't know what the next number was. I mean, 18.88 may have been the right number. It depends on what the number was after the 7. I don't know what that number was. So, but either way, no, it would not be bad. You would be off by, if there was, say, for example, the correct number was 18.871, then it should be 18.87. I don't know why you would round that up to 18.88. But if it was 18.877 and you rounded it up to 8, then you would be correct and everybody else would be wrong. But it doesn't matter. No, rounding up or down, I'm not going to take off for. I don't care. All right, let's take the next one for MG26. This time, again, 2 decimal places, like I had to do there, 2 decimal places. 0.1117 times 25.983. God bless you. Do the math for that one. What did you get for that one, Emily? This Emily.
2.902.
2.902. Anybody else get that? Okay, good. So there we go. We have all 3 of those. For those of you who were absent or don't remember how to do this, that's the weight. That's the amount. You took care of the fact that 78% of it's magnesium 24. So you took care of that fact by multiplying. Now you simply add them up to get the full weight of the average isotope. And you should get, this is the beauty of this answer you already know. It should be that number up there, or at least very close to it, 24.305. Now, if you do it, it actually turns out to be 24.30 because you can't use those, can you? Least number of decimal places when adding and subtracting. So is it 24.30, I think, right? Did y'all get that? I hope. Am I right? Okay. All right, almost done.
Wait, is there a unit attached to that? AMU?
Yes, all these, and I kept them here, but I didn't say them here. And again, on review days, I'm usually a little sloppier, trying to do it faster. But yes, they should all be AMUs, atomic mass units. All right. Last one I'm going to do here. Now here, I will give you a chart, and I've given you in every one of these, 1, 2, 3, 4, 5, 6 different ways to ask the question. Here I gave you just the element and the mass number. Here I gave you neutrons and electrons. Here I gave you, oh, well, I guess that was exactly the same. I could have put one here, as I will do one, where we do the nuclear symbol instead of this hyphen notation. You know, the mass number and atomic number, mass number and protons, protons and neutrons. Every one of those has enough information. You know what people do here as a mistake? They, for those mass numbers, think, well, I didn't get the mass number, so I'm going to look at a periodic table and see what the mass number is. You can't do that. Those are not the mass numbers in the periodic table, are they? They're the atomic masses. Talked about those. All right, so let's do this first one. Lithium 8. That 8 is the mass number. And I didn't hit the button. Here we go. Right? All right, at 8 is the mass number. How do I know how many protons I have? Just cut that in half. That's what some people want to do. How do you know? You don't know. There's no way you could know how many protons lithium has unless you have a periodic table, which is why you'll have a periodic table in every single test. How many does he have, Emily?
3.
3. If that's 3, if he has 3 protons, he has 3 positive charges. Well, you better have 3 negative charges to be neutral. So he has 3 electrons. And his atomic number is 3 because the definition of the atomic number is the number of protons. All right, if you've got 8 for the mass number, remember what the mass number is. It's protons plus neutrons. P plus A, protons plus neutrons. Here's your protons. Okay, neutrons I don't know, but it has to equal 8. So 3 plus what equals 8? What is it? 5. You subtract the number of protons from the mass number. Mass number is protons plus neutrons. All right, here I've got neutrons, here I've got electrons. What columns are always going to be the same?
Protons and atoms.
Protons. Which ones? Protons, electrons, and atomic number. Okay.
Oh, I thought you meant same as the electron.
Well, it's true. Which one's going to be the same as electrons? Protons, electrons, and atomic number. But I thought somebody said neutrons, but that's not true. Okay. Protons and neutrons added together gives me 16. Now, say I asked this one, instead of like I have these two in hyphen notation, say I wanted the nuclear notation, which I will on the test. I have to know what element I'm talking about. What element is element with the atomic number of 7? It's nitrogen, if you look up there. So I write N. And I write 16 over 7 like that. Now, you didn't have to do that. You probably did write nitrogen 16. All right, chlorine 40, again. I'm going to skip this one because we've already done one just like that with lithium. Let's do this guy down here. Mass number is 30. Atomic number is 16. If he's 16, he's 16. And so is he. And I would get, what, 14 for the neutrons, because that's subtractable. And the element would be the element that is number 16, which is sulfur, I believe. Sulfur. Sulfur dash 16?
No, 30.
30. Yeah, you got to use the mass number, not the atomic number. All right. Mass number, protons, 53, 53. Uh-oh. Sorry about that. I was touching. If you touch the board here and then touch it here, it makes a line. See that? I was accidentally pressing against it. Okay. Well, I just erase that one. We already did all the other ones. So 53, 53, 53. Mass number is 108. 108 minus 53 is what? 55, right? And that makes him, guy with 53 is iodine, I believe. Yep, iodine. Dash 108. Right? Final one, 33 protons means 33 electrons to balance them out. And an atomic number of 33, which means the number of protons. Mass number is going to be 59. Is that right? And that would be arsenic. Dash 59. And there you have it. So what do you have? Yeah, question.
Okay, so if you're looking at like the periodic table, the atomic number and the atomic mass are both on. The mass number is.
That's right. The mass number is not on the periodic table. The mass number is simply the protons plus the neutrons.
Okay.
These two guys added together. All right. Now, what I would do for tonight, I would study the names of those guys, the modern atomic theory, the stuff about their experiments, and make sure I know all the terms. Look at the new terms. They're all on the board over there.